Imagine this, July 1943. The Kursk salient. Inside a German Tiger tank, the crew feels almost invincible. 80 tons of the finest Krupp steel. A powerful gun. Zeiss optics. They are the kings of the battlefield. All around them, Soviet tanks burn like tin cans. The tank commander, an experienced NCO, scans the horizon through his periscope, searching for the next target. There, a T-34. A classic model with a 76mm gun. Easy prey. The German gunner locks it into his crosshairs. Distance, about 800 meters. A perfect range for the Tiger. Deadly for the T-34. The Soviet tank jolts. A flash bursts from its short barrel. The German crew doesn't even flinch. They've seen it hundreds of times, Soviet shells bouncing harmlessly off their thick frontal armor, leaving only scratches in the paint. It usually sounded like peas hitting a steel wall. But this time was different. Instead of the familiar dull thud that signaled a ricochet, there was a sharp, dry crack, like the snap of a whip. Something small, almost invisible, pierced the Tiger's 100mm turret armor as easily as a needle through cloth. For a fraction of a second, the inside of the Tiger blazed with daylight. A shower of molten metal and tungsten fragments spread across the fighting compartment, turning everything into a fiery inferno. The crew died instantly, never understanding what had killed them. Later, when German engineers and repair crews examined the destroyed tank, they were baffled. The entry hole was perfectly round and surprisingly small, no larger than a coin. No jagged edges, no blast marks. It looked as if someone had drilled through the armor with a giant drill bit. How? How could an obsolete T-34 with its weak gun penetrate the front of the Reich's best tank? German intelligence had reported that the Soviets had no shells capable of such a feat. Official data confirmed it. The 76mm F-34 gun was helpless against the Tiger's frontal armor. Was it just a lucky shot? A hit in a weak spot, perhaps the vision slit? Or had the Russians developed something new, something secret, that wasn't in any handbook? That tiny hole in the Tiger's armor marked the beginning of a great mystery. The mystery of the forbidden shell, a shell that wasn't supposed to exist, a secret kept silent for decades. To understand where this ghost shell came from, we must go back a little earlier, to the harsh year of 1942. The euphoria over the early successes of the T-34, which the Germans had nicknamed the miracle tank, was beginning to fade. German engineering was not standing still. They had learned their lessons quickly, the shock of 41. Modernized Panzers began to appear on the battlefields. For example, the Panzer IV received a new long-barreled gun. Its shells could now penetrate the T-34 at long ranges, but that was only the beginning. Soviet intelligence brought worrying reports. In Germany, work was in full swing on fundamentally new heavy tanks, machines with armor so thick that the standard ammunition of all Soviet guns would be simply powerless against them. Put yourself in the shoes of a Soviet designer or military engineer of that time. You know the enemy is about to roll out more monsters. Your industry, evacuated beyond the Urals, is working at the limit. To design and mass-produce a new, more powerful tank or a new, more powerful gun quickly, that task is almost impossible. It takes time, resources, retooling whole factories, and there is no time. The enemy is already at the gates of Stalingrad. An answer was needed, fast, cheap, and effective. A solution that would give the old, proven T-34 a second wind and allow it to take on the new German beasts. What was needed was not a new gun but a new shell for the old gun. The idea hung in the air. Engineers around the world were experimenting with munitions that could increase penetration. But Soviet specialists needed not just theoretical research, they needed a miracle. A weapon producible under total war conditions that would give an ordinary T-34 crew a chance against the latest German designs. The task seemed impossible. Standard armor-piercing projectiles, essentially steel castings, had already reached the limits of their capabilities. There was nowhere to increase their speed, the propellant wouldn't allow it. Making them harder was difficult, too. A fundamentally new approach was needed. And that approach was found in one of the rarest and most refractory metals on the planet. Let's peek into the turret of an ordinary T-34 somewhere on the southern front in the winter of 1942. The crew are yesterday's tractor drivers, combine operators, factory workers. They love their machine. It is fast, maneuverable, reliable. But in battle against the new German tanks they increasingly feel helpless. Here's what a typical engagement looked like for them. The commander spots a German tank ahead. Armor piercing on the fascist, he shouts. The loader, sweating, pushes a heavy steel slug into the breach. This is the standard Br-350A shell or its improved version Br-350B. The gunner catches the target in his sights, gently pulls the trigger, fire. The tank shudders. Everyone strains to see toward the enemy and sees a spray of sparks. The shell. Engineers decided to apply this same principle to a tank shell. What if, instead of a solid steel slug, you made a composite shell, a light outer body with a very small but incredibly dense and hard core inside? When fired, the lighter shell could be accelerated to much higher speeds than a heavy one. Upon impact, the outer shell would shatter, and the small, super-dense, high-velocity core, like that steel rod, would continue forward by inertia, punching straight through the armor. This concept was called the subcaliber shell. Subcaliber, because the diameter of its main penetrating core was significantly smaller than the gun's bore. And to make that core, that steel rod, engineers chose one of the densest and hardest metals on Earth, tungsten. Tungsten is nearly twice as dense as lead and rivals steel in hardness, the hardness of the best tool steels. A tungsten carbide core, an alloy of tungsten with carbon, was the ideal candidate to serve as an armor killer. It did not melt on contact with armor and did not deform, preserving all of its kinetic energy for penetration. The projectile designated GAU-530 Br-350P had a rather clever design. It consisted of a tungsten core seated in a steel driving cap. Over that was fitted a light aluminum or steel jacket with a ballistic cap for better aerodynamics. In common speech such shells were nicknamed spindles because of their distinctive shape. When fired, the whole assembly flew toward the target. On impact the light jacket crumpled, while the small but very heavy, extremely fast core kept going and punched through the steel. It was an elegant and deadly solution. It required no change to the gun or the tank. It gave the old 76mm gun a completely new, almost unbelievable capability. The development of the subcaliber shell was a true engineering thriller. The work was led by the talented designer Nikolai Romanovich Burmistrov. His team faced several fiendishly difficult problems. The first and foremost was, where to get tungsten. The USSR had its own deposits before the war, for example, the Chernobylskoye deposit in the Caucasus, but by 1942 the Caucasus was either occupied or in the frontline zone. Mining had practically stopped. Tungsten overnight became a strategic resource as valuable as gold or platinum. It was needed not only for shells, filament wire for lamps, welding electrodes, and, most importantly, cutting tools for machine tools. Without tungsten cutters, the entire defense industry producing tanks, aircraft and guns would grind to a halt. Every gram of tungsten counted. Some came from Lend-Lease allies, but it was catastrophically little. Engineers therefore had to perform real miracles of economy, calculating the shape and size of the core to achieve maximum effect with minimal use of the precious metal. The second problem was accuracy. A projectile of this unusual construction did not behave in flight like a conventional solid slug. It was necessary to select the ideal shape of the jacket and ballistic cap so that it would fly true and not tumble. Dozens of wind tunnel tests were carried out. The third task was the so-called driving cap or sabot. This part had to reliably guide the core along. The driving cap had to reliably guide the core along the bore and then not interfere after it exited. But sometimes it separated improperly and knocked the projectile off course. That also required long, painstaking experiments. The work proceeded under the strictest secrecy. All drawings, calculations and test protocols carried a top secret, of special importance, classification. The designers worked around the clock, sleeping right on the shop floor. They understood that thousands of lives at the front depended on their success. This was not just a job, it was their personal fight against German Tigers and Panthers, a battle waged on drawing boards and proving grounds. And they won that battle. By the end of 1942 the first experimental batches of the new round were ready for testing. Why such tight secrecy? One might think a new weapon is a cause for pride, for propaganda. They could have trumpeted to the world that the Soviet Union had an answer to the German beasts. But the Stavka, the High Command, reasoned otherwise, and for several weighty reasons. First, as we have already said, tungsten was the Achilles heel of the whole project. If the Germans discovered that the new Soviet shell's effectiveness depended directly on that rare metal, they would do everything possible to cut off the remaining supply routes. They would intensify bombing of transport hubs, expand submarine warfare against Lend-Lease convoys. Revealing the shell's secret would jeopardize the entire production program. Second, the element of surprise. War is not only a clash of iron but a contest of minds and intelligence. Imagine the shock of German tank crews and engineers when their supposedly invulnerable tanks suddenly began to be penetrated by a gun they considered obsolete. It sows doubt and fear, forcing them to question their superiority. The Germans would have to spend precious time and resources to understand what was happening and to develop countermeasures. In war, time equa. Third, they did not want to show their cards prematurely. Mass production of subcaliber shells was impossible, there were very few of them. If their existence became widely known, it would create unrealistic expectations at the front. Soldiers would wait for a miracle weapon that simply wasn't available in sufficient quantities. It was far more effective to use it surgically, like a scalpel, at the most important points and on the most dangerous sectors where its employment could yield the greatest tactical effect. Therefore the project was classified at the highest level. Documents relating to, the documents governing the production and distribution of the Pz.III were filed under a special folder classification, access to which was granted only to a narrow circle within the State Defense Committee. Even at the front many commanders did not know exactly what had been brought to them in the special sealed crates. Instructions were oral and utterly laconic: this is a special munition. Use only against heavy tanks. 1 or 2 per vehicle, strictly accounted for. Thus was born the legend of the forbidden shell, a weapon that existed, but of which almost no one knew. Finally the day of decisive trials arrived. Trophy equipment was brought to the proving ground outside Moscow. Among it was one of the first captured Tiger tanks taken intact. Opposite it, at standard range, they set up an ordinary 76mm tank gun taken from a T-34. Senior officers from the main artillery directorate and representatives of the People's Commissariat for Armaments were present. The atmosphere was tense. First they conducted a control shot. They fired at the Tiger with a standard service armor-piercing round, the Pz.III. The shot rang out, and everyone saw the familiar picture: a spray of sparks and a small dent on the Tiger's frontal armor. The armor was not penetrated. That only confirmed the worst fears. Third, they did not want to show their cards prematurely. Mass production of subcaliber shells was impossible, there were very few of them. If their existence became widely known, it would create unrealistic expectations at the front. Soldiers would wait for a miracle weapon that simply wasn't available in sufficient quantities. It was far more effective to use it surgically, like a scalpel, at the most important points and on the most dangerous sectors where its employment could yield the greatest tactical effect. Therefore the project was classified at the highest level. Documents relating to, the documents governing the production and distribution of the Pz.III were filed under a special folder classification, access to which was granted only to a narrow circle within the State Defense Committee. Even at the front many commanders did not know exactly what had been brought to them in the special sealed crates. Instructions were oral and utterly laconic: this is a special munition. Use only against heavy tanks. 1 or 2 per vehicle, strictly accounted for. Thus was born the legend of the forbidden shell, a weapon that existed, but of which almost no one knew. Finally the day of decisive trials arrived. Trophy equipment was brought to the proving ground outside Moscow. Among it was one of the first captured Tiger tanks taken intact. Opposite it, at standard range, they set up an ordinary 76mm tank gun taken from a T-34. Senior officers from the main artillery directorate and representatives of the People's Commissariat for Armaments were present. The atmosphere was tense. First they conducted a control shot. They fired at the Tiger with a standard service armor-piercing round, the Pz.III. The shot rang out, and everyone saw the familiar picture: a spray of sparks and a small dent on the Tiger's frontal armor. The armor was not penetrated. That only confirmed the worst fears. Then the loader took up the unusual light projectile, shaped like a spindle. In the ensuing silence his movements seemed especially slow and ceremonial. He rammed the round into the breech. The command, fire. The shot sounded different, sharp, dry. Everyone held their breath. A moment later a neat little hole appeared in the center of the Tiger's frontal plate, from which a thin wisp of smoke issued. The commission approached the tank. Incredible. The 100mm armor, hardened by the finest German techniques, had been pierced through. Peering inside through the open hatch, the engineers saw a horrifying scene. The entire interior of the fighting compartment had been raked by fragments. Melted bits of metal protruded from seats, instruments, and walls. It was obvious that had there been a crew inside they would have had no chance. The tests were repeated several times at different ranges and angles. The result was the same each time: reliable penetration. The subcaliber round worked. It truly transformed the T-34's gun into a fearsome anti-tank weapon capable of taking on the latest German designs. The test report was laid on the desk of the country's highest leadership. The decision was made to immediately put the round into serial production, but with one very important condition. Considering the tungsten shortage and the necessity of keeping the secret, production will strictly limited. This shell would not become mass-produced. It would be a weapon for the chosen few, a special tool for solving the hardest tasks. The order was given. The machinery of the war industry began to turn slowly to produce the first top-secret batches of Tiger killers. So the round was adopted. But how to deliver this secret weapon to the front so that nobody would suspect its existence? That was a separate special operation. Pz.III shells were never supplied to the troops like ordinary ammunition. They were not loaded into wagons and sent to General Army depots. Every round was strictly accounted for. Production was concentrated at several especially guarded plants. Finished shells were packed in special wooden crates that bore no standard markings. Instead of the usual inscriptions, armor-piercing, or high explosive, they carried code designations. These crates were transported under armed guard, often accompanied by NKVD officers. They were not issued to every unit but sent to specific addresses by special Stavka orders. First to receive them were Guards, Tank Corps and armies operating on the most critical sectors of the front. Before major offensive or defensive operations where many German heavy tanks were expected, an elite unit would receive a special cargo. The commander of a tank brigade or regiment was ordered to accept several such crates. Issue was made personally by the tank commander or even directly to the gunners against signature. Often this happened at night under strict secrecy. Tank crews were given only a few rounds per vehicle, usually 2, rarely 3 or 4. This was an untouchable reserve. They were to be stowed in the ammunition rack in a strictly defined spot so that in the heat of battle they could not be confused with ordinary shells. These few spindles were the crew's last argument. They were forbidden to be spent on light targets, armored personnel carriers, artillery pieces, or medium tanks. Entrusted by the motherland with its most important secret in the fight against German armored vehicles, a logical question arises: how were tank crews taught to use this new, unusual weapon? The answer may surprise you: practically not at all. There were no mass courses, no special training chutes. Wide-scale training would have blown the secret completely. Imagine if tankers on every range began firing the spindles, the information would inevitably leak to the Germans. Therefore training, like supply, was targeted and informal. Everything rested on oral instructions and personal experience. When a crew received its 2 or 3 precious rounds, the company or battalion commander, himself briefed by a representative from the army staff, gave the instruction. The briefing was deliberately simple. Comrades, this is a new subcaliber round. You see, it's lighter and shaped differently. It flies much faster than a regular shell, so use less lead on a moving target. It's very accurate but loses power at long distances. The most effective range is up to 500 meters. Remember, its job is to pierce armor, it does not detonate inside like a high-explosive fragment. It goes right through the tank and kills the crew and equipment with glowing fragments of armor and of the core itself. Therefore aim at the places where the crew sit, or where the ammunition is stored in the turret, the central part of the hull. And most importantly, don't waste it, use it only on Tigers and Ferdinands. Understood? That was the whole training. No complicated ballistic tables, no abstruse lectures, a simple, clear instruction for the frontline soldier. The psychological effect of possessing such a weapon was enormous. A crew that had those 2 spindles in the ammo rack felt much more confident. They were no longer punching bags. They had a chance, a real chance, in a duel with a German heavyweight. It was like giving an infantryman with a rifle a couple of silver bullets against a werewolf. He still takes a risk, but now he has something to fight back with. That confidence was priceless. It allowed crews to act bolder, not to fear frontal attacks, knowing that at the decisive moment they would have an argument in the barrel that German armor was powerless against. And what about the Germans? How did they react to the appearance of mysterious holes in the armor of their best tanks? At first, complete bewilderment. Early reports from the front, from near Leningrad and Stalingrad, where the first Tigers appeared in late 42 and early 43, provoked only skepticism among German commanders and engineers. In the reports about, descriptions of losses increasingly contained strange accounts. Crews of knocked-out tanks who had the fortune to survive reported a sharp, dry blow and the instantaneous death of their comrades. Repair teams reported small, perfectly round holes in the thickest armor. Early explanations varied. They thought it might be the result of hits from aircraft guns or fire from some new, ultra-powerful anti-tank artillery. The idea that this was the work of a standard T-34 tank gun was not taken seriously for a long time. German specialists were confident in their calculations. According to their tables, a 76 mm shell could not penetrate a Tiger's 100 mm frontal armor under any circumstances. So such cases were written off as statistical anomalies, for example, hits in weakened zones where armor plates joined, or defects in a particular armor plate. German intelligence, the Abwehr, was also silent. They had no information about a new Soviet munition. Agents working in the Soviet rear reported nothing. Analysis of open sources, newspapers and radio broadcasts, yielded nothing either. The subject was completely closed. The situation began to change by the summer of 1943, ahead of the Battle of Kursk. The number of Tigers and Panthers on the front rose sharply, and with it the number of cases of their mysterious destruction. When such reports started arriving by the dozens, they could no longer be ignored. German engineers began to study the damaged equipment seriously. They cut out pieces of armor with the mysterious holes and sent them back to laboratories in Germany. Chemical analysis of fragments embedded in the armor showed the presence of tungsten. That was the first key to the mystery. The Germans themselves were conducting active development of subcaliber rounds with tungsten cores, the so-called Panzer 40. They understood the physics of the process perfectly, but it came as a complete surprise to them that the Soviet Union, which they regarded as technologically backward, had not only developed but managed to organize production of such a complex munition under the harsh conditions of total war. The German command was shocked. The secret of the small hole in the armor was beginning to be revealed. Let us try to reconstruct one of those battles, based on veterans' memoirs. Imagine a small village somewhere near Belgorod in the midst of the Battle of Kursk. Morning. From a grove on the village edge 3 gigantic silhouettes crawl out, tigers. They move slowly, unhidden, firing at Soviet positions. Panic begins in the trenches. Infantry can do nothing against these monsters.